In this video, I am going to deal with the revisiting rational numbers and their decimal expansion. Before going into the problems, we must know three theorems related with this. Then only we can find whether it is a terminating one or it is a non-terminating recurring one. First one, let x be a rational number whose decimal expansion terminates. Then we can express x in the form of p by q, where p and q are co-prime and the prime factorization of q is of the form 2 raised to n into 5 raised to m, where n, m are non-negative integers. That means if an expression is given, we have to find out whether it is a terminating decimal expansion or it is a non-terminating repeating expansion. So first we have to express this rational number in the form of p by q. Then we have to determine this p and q in terms of 2 raised to n into 5 raised to m. If it is in the terms of 2 raised to n into 5 raised to m, then we can say that those decimal expansion terminates. If it is not of the form 2 raised to n into 5 raised to m, that means that those decimal expansion not terminates. Then second theorem, let x is equal to p by q be a rational number such that prime factorization of q is of the form 2 raised to n into 5 raised to m, where n, m are non-negative integers. Then x acts a decimal expansion which terminates. Here also same concept, only difference is that here we are not considering p and q as co-prime numbers. Here we are considering p by q as a rational number and q is of the form, this denominator is of the form 2 raised to n into 5 raised to m, where n, m are non-negative integers. If it is of the form, that is this denominator is of the form 2 raised to n into 5 raised to m, that means that those decimal expansion terminates. Then next theorem, x is equal to p by q be a rational number such that prime factorization of q is not of the form 2 raised to n into 5 raised to m. That means denominator is not of the form 2 raised to n into 5 raised to m. Then x has a decimal expansion which is non-terminating repeating. So if it is not of the form 2 raised to n into 5 raised to m, then it is non-terminating repeating. If the denominator is of the form 2 raised to n into 5 raised to m, that means decimal expansion terminates. You have to remember this concept only. If denominator is of the form 2 raised to n into 5 raised to m, that means those decimal expansion terminates. If it is not of the form, denominator is not of the form 2 raised to n into 5 raised to m, those decimal expansion is non-terminating repeating. We can see this by means of some examples. Your first question is 64 by 455. We have to find this decimal expansion is a terminating decimal expansion or non-terminating decimal expansion. This can be expressed in the form of p by q. We have to determine only q. We have to find this q in the form of 2 raised to m into 5 raised to n. This only we have to find out. So 455, first find out the prime factorization of 455. First we can divide 455 by means of 5, then it is 91, then 91 is only going through 7, then 13 into 7 is 91. So we can express this 455 by means of 5 into 7 into 13. So it is not of the form 2 raised to m into 5 raised to n because it consists of 7 and 13 as its factors. So we can say that this decimal expansion will be non-terminating repeating one. this decimal expansion is a non-terminating repeating one, since it contains 7 and 13 as its factors. So let's go through second question. 1600 can be factorized as 1600 divided by 2, 800, 2, 400, 2, 200, 200, 50, 25, 5, 5. So 1600, which is the cube, which can be written it as 2 raised to 6 into 5 raised to 2. That means it is expressed in the manner 2 raised to m into 5 raised to n. So it is a terminating decimal expansion. Your next question is 29 by 343. 343, which is the cube, denominator is 343. So first we have to find out the factorizing prime factors of 343. 343 divided by 7. 343 by 7. 343 can only be factorized by using 7 only. 343 by 7, which is 49. 7 sevens are 49. So this can be expressed as 7 cube. It is, since the denominator is not of the form 2 raised to m into 5 raised to n and it has got 7 as its factor, the decimal expansion of 29 by 343 is non-terminating repeating. This decimal expansion is non-terminating repeating. Non-terminating repeating. Your fourth question is 77 by 210. This can be represented as 210 can be factorized as 210 by 2, which is 105. 105 by 3, 35, then again by 5, which is 7. So this can be represented as 77 can be denoted as 7 into 11 is 77. Denominator 210 can be represented as 2 into 3 into 5 into 7. So it is equal to this 7 and this 7 cancelled. So which is equal to 11 by 2 into 3 into 5. Since the denominator is not of the form 2 raised to m into 5 raised to n, it has 3 as its factor. The decimal expansion of 77 by 210 is non-terminating repeating. Fifth question is 35 by 50. 35 by 50, which can be represented as 35 means 5 into 7. 7 5s are 35. 50 can be represented as 50 by 2, which is 25, then 5, 5. So it can be represented as 2 into 5 into 5. This 1, 2, this 1, 5 and this 1, 5 cancels. This 2 remains here only. So it is of the form 2 raised to m into 5 raised to n. Since denominator q is of the form 2 raised to m into 5 raised to n, hence the decimal expansion of 35 by 50 is terminating. So you have to consider both numerator and denominator. If any of them cancel each other, you can represent, and you can represent in the form of 2 raised to m into 5 raised to n, which those decimal expansion can be called as terminating decimal expansions. if it is not in the form of 2 raised to m into 5 raised to n, which is known as non-terminating repeating decimal expansions.